everyone, welcome back to my channel. So today in this video we are going to see lesson number 1 of maths, that is integers. So this is part 3 of it. I have made part 1 and part 2. So in the part 1 we discussed that what are integers, absolute value, number line and comparison of integers. In the part 2 we saw operations on integers such as addition, subtraction, multiplication and division. And in this video we are going to see the properties of integers. So let us begin with the video. Property of addition. Closure property. Now for example, you have to add 3 with 4. So you are getting 7 as the answer. Right? So here as you can see, this is 3. This is an integer. This is 4. This is also an integer. This is your answer, that is 7. Now this is also integer. Now for another example, you have to add -7 with 5. So here you are getting -2 as the answer. As you can see, -7 is an integer. 5 is also an integer. So we are adding integer with integer and we are getting the answer as integer, as -2 is also an integer. So in short, the sum of two integers is always an integer. This property is called the closure property of addition of integers. For example, we have to add 40 with 10. So here we will get 50 as the answer. Right? Now if I change the sequence, that means I tell you to add 10 with 40. So 10 plus 40 is also 50 only. Right? So which property is this? After adding 40 with 10, then also I am getting 50. And after adding 10 with 40, then also 50 is only my answer. So this property is known as commutative property of addition. In short, the sum of two integers remains the same even if their order is changed. That is, if I am adding 40 with 10, then also I am getting 50, and adding 10 with 40, then also I am getting 50 as the answer. So this is known as commutative property. Associative property of addition. For example, we have to solve -16 plus 15 plus 13. As you might know, we solve the brackets first. So we will solve 15 with 13 first. As you know, 15 plus 13 is 28. So is equal to -16 plus 28. As you know, minus and plus becomes minus. So we are going to do -16 minus 28. After subtracting 28 from 16, we are getting 12 as the answer. As bigger value is 18, which has positive sign, so the answer is also coming in positive. So you can see here the answer is coming 12. Now for example, I change the grouping now. That means that for example, I have to add 13 plus -16 plus 15. As you know, we have to solve the brackets first, so we have to solve -16 plus 15. As you know that minus and plus becomes minus, so we have to perform minus operation. So 16 minus 15 is 1. I have kept minus sign because greater value is 16, which has minus sign. So we are putting minus sign here. As you can see, this is positive and this is negative. So positive and negative makes minus operation. So we have to subtract 13 from 1. So we are getting 12 as the answer. As greater value is 13, which has positive sign, so the answer is also coming in positive. So the answer is coming same. So that means that the sum of 3 or more integers remains the same even if their grouping is changed. That is, if I am adding minus 16 with 15 with 13, then also I am getting 12, and after adding 13 with minus 16 plus 15, then also I am getting 12. Now for example, I tell you to add 10 with 0. So you will say that the answer will be 10 only, right? If I tell you to add minus 60 with 0, so then also you will say that the answer will be minus 60 only. So in short, when 0 is added to any integer, the value of the integer remains the same. That is, if I am adding minus 60 with 0, so then also I am getting minus 60 as the answer only. If I am adding 10 with 0, so I am getting 10 as the answer only. So that means that any number added with 0, so whichever number is added with 0 will be the answer. So 0 is called the additive identity for integers. Additive inverse. For example, we have to find the additive inverse of 3. So answer will be the opposite of 3. So opposite of 3 is minus 3, right? That means that right now 3 is a positive integer. If I have to find the additive inverse, so it will become a negative integer. The sign will be changed. Right now 3 has plus sign. But when I have to find the additive inverse, I will put minus sign before 3. So here I am getting minus 3 as the answer. For example, the additive inverse of minus 30 will be 30. Right now, this minus 30 is a negative integer. It has minus sign. But when I have to find additive inverse, so I will just change the sign. Here it is minus, I am putting plus over here. Here it is negative, this is a positive integer. So in short, here minus 3 is the additive inverse of 3. 30 is the additive inverse of minus 30. You can also remember through one method I use, like inverse means ulta. So in short 3 का उल्टा minus 3 होगा और minus 30 का उल्टा 30 होगा. So I hope you understood the additive inverse. Coming towards the last property of addition, that is property of 1. For example, I have to add 5 with 1. So I am getting 6 as the answer. For another example, I have to add minus 10 with 1. So I am getting minus 9 as the answer. So what can you observe in these examples? You can observe that the successor of 5 is 6. The successor of minus 10 is minus 9. That means that when 1 is added to any integer, we get its successor. So this is known as the property of 1. Properties of subtraction. Closure property. Closure property of subtraction is as similar as to closure property of addition. Now for example, we have to subtract 10 from 5. So we are getting 5 as the answer here. As you 10 is an integer and 5 is also an integer. The difference of these both integers is also an integer. For example, minus 5 minus 4 is your question. So here we are getting minus 1 as the answer. So here minus 5 is also an integer, minus 4 is also an integer, and the difference of both the integer is also an integer. So in short, the difference of two integers is always an integer, as you can see in both of these examples. Commutative property. For example, we have to subtract 30 from minus 20. So here we will get 50 as the answer. But if I tell you to subtract minus 20 from 30, so at that time our answer will be minus 50 here. As after adding these both we will get 50, greater value here is 30, which has negative sign. So the answer is also coming in negative. So what can you observe here? We can observe here that after changing the order of both the integers, we are getting different answer. So that means the order of integers while doing subtraction is important, because if we are changing the order, so the result is also getting changed, as you can see in both of these examples. So in subtraction we need to make sure that whatever the question is asked, we have to write that in the correct order. If we are writing in the wrong order, so the answer will be also coming wrong. These two examples ensures that commutative property under subtraction does not hold true. Associative property. Now for example, we have to subtract 32 from 22 minus 2. Now first we will solve the brackets, that is 22 subtracted by 2. Now 32 subtracted by 20 gives 12 as the correct answer. Now if I ask you to subtract 32 from 22 minus 2. As you know, we have to solve the brackets first. So after subtracting 32 from 22, we get 10 as the answer. 10 minus 2 is equal to 8. So it's being clearly watched that both of this answer and this answer is totally different. So this thing improves that when the grouping of integers is changed while doing the subtraction, so the result is also changing, as you can see here in the examples. So this proves that associative property does not hold true for the subtraction of integers. For example, we have to subtract 50 from 0. So we are getting 50 as the answer here. Similarly, minus 7 subtracted by 0 is equal to minus 7. So in short, again, when 0 is subtracted from any integer, we get the same integer, as you can see in the examples. After subtracting 50 from 0, we are getting the integer 50 as the answer. Similarly, after subtracting minus 7 with 0, we are getting minus 7, that integer only, as the answer. So this property is known as the property of 0 of subtraction of integers. Property of 1. For example, we have to subtract 12 from 1. So we are getting 11 as the answer here. Similarly, if we have to subtract -8 from 1, so we are getting -9 as the answer here. One thing which can be observed from this example is that when 1 is subtracted from any integer, so we are getting its predecessor. So this is known as the property of 1. Now let me inform you one thing, that if you want to find the predecessor and successor of negative integers, you must see the number line. So it will be better and it will be more easy for you to understand the predecessor and successor in the number line.